Hello. So we're going to do this. It's fun. It's like a shortcut. It seems longer, but it's not. So second derivative test. We've been talking about the second derivative and concavity. And now we're going to use the critical numbers and the second derivative to find extrema. Extrema are the max or min. So we used to use the first derivative, but that was a lot of work, and we had to find the intervals where the function is increasing and then decreasing and then increasing, and then we go, oh, there's a max here or a min here. But sometimes we're only given the second derivative, and I'll explain how we can get the max or min from the second derivative. So while the second derivative is primarily used to determine intervals of concavity and points of inflection, it can also be used to identify relative max and mins. And so we're going to fill this in. If x equals a is a critical number, then you should have memorized that the first derivative is equal to 0, or f of a is undefined. That's not right. Shouldn't it be the derivative? Okay. Now I'm second guessing myself. Making x equals a potential max or min. The derivative is undefined. What would that be, like a corner or a cusp? Okay. Ready? If the second derivative is positive, then we know f is concave up. Don't say it. F is concave up. Now think about this. You ready? If the second derivative is positive and you have concave up, what does that make this point? That makes a relative minimum, right? And if your function is concave down at a, then what do you have? You have a relative maximum. If the second derivative is not positive or negative, so it's not concave up or concave down, well, that means it's a point of inflection, and the point of inflection is not a max or a min, so you can't use that test. So pause if you need to fill that in, but we're going to move to the examples, and the goal is to get these two examples completed on this video. Ready? I'm going to do real clear steps for you. We're going to use the second derivative. So don't cheat and use the first derivative, okay? We're going to use, sometimes, you ready? Why would we ever use this? Sometimes you're only given the second derivative and you're not given the original function or the first derivative. So use the second derivative of this function to locate and classify all x values of relative extrema for each function. So I'm going to write out steps here, okay? So step 1 is to find f prime. Of course, we always start with a very easy polynomial to get used to the steps. Good. Derivative, power rule, and derivative of 2 is 0. Is that it? Oh, we have to find the critical number, so don't jump to the second derivative yet. Find critical values. So critical values, critical numbers are where the first derivative is equal to 0 or the first derivative is undefined. So where is this first derivative equal to 0? I'm going to factor. So what's the greatest common factor? We have a 4, we have an x squared, and if I factor out the greatest common factor, what's left in parentheses here? We have x minus 3. So it looks like the critical numbers are going to be, what 0 do we get from 4x squared? So we're going to get 4x squared equals 0. Divide by 4, take the square root, so x equals 0. And if x minus 3 equals 0, then x equals 3. Here are the critical numbers. Is a cubic, is this ever undefined? Think about 4x cubed. That would be something like that. That's defined everywhere, so the only critical numbers are at 0 and at 3. Now, instead of doing a first derivative sign chart, we're now going to go to the second derivative. And then all we're going to have to do is plug these in to the second derivative. So f double prime is the derivative of the first derivative, so that's going to be 3 times 4 is 12, x squared. 2 times 12 is 24x. Now, we don't have to factor, we don't have to solve, okay? So step 4, ready? We're going to plug in critical numbers to the second derivative, and all we're going to see is if it's positive or negative. Ready? So f double prime of 0 is going to be 0 minus 0. Is that positive or negative? It is neither. So there's actually no max or min at 0. Neither a max or min, or nor. Okay, and then f double prime of 3, we're going to do 12 times 3 squared minus 24 times 3, and the goal is to see if this is positive or negative. So 12 times 9 minus 3 times 24. I have a final answer here of 36, and is that positive or negative? Positive. So we say that's an S, since f double prime of 3 is positive. This is our conclusion. That's not the letter F. F of x is concave. What does it mean? Second derivative is positive, so it's concave up at x equals 3, making f of 3 a, let's think about this. If it's concave up, then we would have a minimum, right? A relative minimum. Okay, ladies and gentlemen, easy concept, easy to do. Are you going to remember all those steps? You're going to need to practice, okay? So, because you're used to doing other things, like you're used to finding the first derivative and then the second derivative, or the second derivative and setting that equal to 0. So it's a silly mix-up of previous steps. So we just have to make sure we have the right steps in the right order. So that's what notes are for, right? In math class? Okay. This is number 1, and number 2, it looks like we have a trig. We're going to try our best to make it fit. Ready? Set. What was step 1? I forgot, so I'm going to look up here. Find the first derivative. So f prime of theta. The derivative of cosine is negative sine. So we're going to say negative 2 sine theta. Now be careful here, that's not 0. The derivative of minus theta will be minus 1. Okay. What do we do next? Find the critical numbers. So we're going to set the derivative equal to 0 and solve for theta. So I'm going to add 1, divide by negative 2. So we're wondering where on the unit circle is the sine equal to negative 1/2. Now if sine is the y value, where the y value is negative? What 2 quadrants? Do you remember? So let's draw a little picture. Here's how I'm going to do it. Ready? I go 1, 2, 3, 1. So I know that this is our y value of 1/2 is pi over 6, but since it's negative 1/2, I'm going to look at this coordinate point, and this coordinate point will give me a whatever negative 1/2, and then a whatever negative 1/2. And so we need the radian measures to those. So going up, it's positive, it's pi over 6. So do you remember over here would be 5 pi over 6, and down here would be 1 pi over 6 past pi. So it's like 1 and my lights. So I don't know how I'm explaining it, but it's 7 pi over 6, and then the angle down here is 11 pi over 6. Okay. Is our derivative ever undefined? So think about the graph of a sine curve. Does it ever have any corners or cusp or anything like that? No. So you should just, how do you know that? Well, you should know what a cubic looks like, and you should know that the sine curve, let's see, this one, it's a sine curve, okay? It would be shifted down 1, and it would be a negative. It would go down 2 and then up 2, like that. All right, what are these again? We're on step 2. Those are our critical numbers. So we're wondering if there's a max or a min at these values. What's step 3? Step 3 would be to, let's look up here, our notes, find the second derivative, okay? So the second derivative of theta, we have -2 sine. The derivative of sine is cosine. So we're going to keep it -2 cosine. And the derivative of -1 is 0. So here's our second derivative. Okay, that was step 3. What do we do next? Step 4, plug in the critical numbers to the second derivative. Plug in critical numbers. So f double prime of 7 pi over 6 cosine an s of 7 pi over 6. Oops, remember when I said whatever that is? Well, now we need it. Okay, the x value here, oh, you know what? We don't really need to know what it is. We just need to know the sign of it. So the sign of this x value is positive. Oh, I'm at the wrong spot. I'm on the next one. That's okay. We're going to make this work. What's the cosine here? It's negative. Do y'all agree? Sorry. What happened? 7 pi over 6, and I was looking at 11 pi over 6, but we're starting with 7 pi over 6. 7 pi over 6 over here. What's the x value? The x value is negative. So we have a -2 times a negative value. It's this. I know what it is, you guys, okay? What's a negative times a negative? A positive, right? Positive. So what do we conclude? If the second derivative is positive, draw a picture, then what do we have? A minimum. So a min at theta equals 7 pi over 6 because, what's the reason? Because the second derivative is positive. Because f double prime is positive. Okay, I knew we were going to run out of room. Let's plug in the other one. 11 pi over 6. Now here we have a negative times a positive, which is negative. So that means that if the second derivative is negative, then the function's concave down, which means what's happening at 11 pi over 6. There's a relative max at 11 pi over 6 because the second derivative was negative. Second derivative, oh my goodness, how are we making this work? Cool. That's it. So what are we going to do here? You agree with two polynomials. Why is that in the wrong order? I don't know, just to wake you up a little bit. Put it in the right order. Use the second derivative test to find the local extrema. What does that mean? Local. Oh, local is the same as relative. And extrema, max and mins. So just like example 1. And then these are kind of review. I like these, so I like them. Challenge. Have fun. Okay? And I'll see you later. Thanks for watching.